Okay, let's spend a little while now looking at the peripheral nervous system. The nervous system is divided, as we've said, into the central nervous system, which involves the brain and the spinal cord, and the peripheral nervous system, which is more complex in some ways than the central nervous system, at least in understanding its divisions. Nerves that make up the peripheral nervous system can be either sensory, that is, they're transmitting information from the periphery to the central nervous system, or they can be motor, that is, they're transmitting information from the central nervous system to the periphery. Sensory nerves can be of two types. They can be transmitting information from skeletal muscle, and these are called somatic nerves, or they can be transmitting information from internal organs, and these are called visceral sensory nerves. Motor nerves, those traveling from the spinal cord to the periphery, can be of two kinds. They can be part of the somatic nervous system, or they can be part of the autonomic nervous system. The somatic nervous system is responsible for voluntary responses, and those are nerves which innervate skeletal muscle and over which we have control, such as being able to move our arm or our leg. Nerves which are part of the autonomic nervous system are involved in involuntary responses, those over which we have no control, like the gut, like secretion of glands, like the contraction of smooth muscle. Smooth muscle is found around your gut, and try telling your gut to contract and you will see that you have no control over your smooth muscle. And to make things a little more complex, the autonomic nervous system, also called the visceral nervous system, is broken down into a sympathetic branch and a parasympathetic branch. And both of these innervate cardiac and smooth muscle and glands. Looking at this diagrammatically, we have on the left hand side here the somatic reflexes, and on the right hand side the visceral or autonomic reflexes. In both cases, a single sensory neuron transmits information from the periphery all the way into the spinal cord. The same is seen on this side, transmitting information, say, from the gut all the way into the spinal cord. In both cases, the cell bodies of these unipolar neurons are situated in ganglia called a dorsal root ganglion. But in the case of the somatic nervous system, this sensory nerve will synapse in the dorsal horn of the spinal cord, and we'll look at the structure of the spinal cord in a little bit, in the dorsal horn of the spinal cord with the dendrites of an interneuron, whereas in the autonomic or visceral side there is no interneuron. The axons of the sensory nerve synapse directly with the motor nerve, which will transmit information to the periphery. Additionally, another major difference is that on the somatic side of the peripheral nervous system, the motor nerve is a single nerve. It will transmit information all the way from the spinal cord out to the periphery, to skeletal muscle, eliciting a reflex. And this nerve here, this motor nerve, can be very long. Think of a nerve which goes, say, from the spine of Shaquille O'Neal down to his toe. That nerve is going to have to be a meter or more in length. On the visceral or autonomic side, there's a chain of two motor neurons transmitting information to the effector organ. The first neuron travels from the spinal cord to a ganglion, a collection of nerve cell bodies lying outside of the spinal, and then the second neuron transmits information from this ganglion to the effector organ. The first neuron is called the preganglionic neuron, and the second neuron, not surprisingly, is called the postganglionic neuron. Peripheral nerves lie outside of the central nervous system, and these nerves, shown here, may be sensory, motor, or mixed. These peripheral nerves thus may contain afferent fibers traveling to the central nervous system, or efferent fibers traveling from the central nervous system. Most peripheral nerves are mixed nerves. All peripheral nerves are surrounded by 3 layers of connective tissue, much as you saw with skeletal muscle. The outermost layer of dense irregular connective tissue, which surrounds the entire nerve, is called the epineurium. The epineurium then penetrates into the nerve, dividing it up into fascicles, and each fascicle contains a bunch of individual nerve fibers. Each fascicle is also surrounded by a specialized epithelial cell, or a layer of specialized epithelial cells, and then the very fine connective tissue which surrounds each nerve fiber or each nerve cell is called the endoneurium. Peripheral nerves may be myelinated or non-myelinated, and we'll look at that in a moment. This section of a peripheral nerve stained with H&E very nicely shows the epineurium dividing this large nerve, and we're only seeing a part of it here, into a number of fascicles. Each of these is a fascicle, and surrounding each fascicle is this layer of specialized epithelial cells forming the perineurium. And the contacts between these epithelial cells are very tight, so these epithelial cells, modified epithelial cells I should call them, provide insulation and protection around the nerve bundle, preventing attack by pathogens and immunoglobulins, etc. And then surrounding each of the many nerve fibers in a fascicle is the very fine endoneurial connective tissue. Now, nerve fibers never go around naked. They are always surrounded by some kind of a glial cell. In the peripheral nervous system, this glial cell is called a Schwann cell. And Schwann cells can surround nerve fibers in 2 different ways. They can either form a myelin sheath around the nerve fiber, or these smaller non-myelinated nerves may lie in grooves surrounded by the Schwann cell. And peripheral nerves may either be myelinated or they may be non-myelinated. In forming a myelinated axon, or in myelinating an axon, the Schwann cell wraps itself around the axon, secretes these layers of myelin which are described in your notes, and then secretes a basal lamina around itself, so that the nerve is surrounded by these layers of myelin and is also surrounded by the basal lamina surrounding the Schwann cell. And the Schwann cell also secretes the endoneurial connective tissue found in between nerve fibers in a nerve bundle. In the case of non-myelinated nerves, the Schwann cell still secretes a basal lamina around itself and secretes the very fine collagen and reticular fibers which form the endoneurium. Now, Schwann cells are teeny tiny little cells, and axons can be very long. and so it takes many thousands of Schwann cells to completely myelinate this very long axon. And you might notice before we go on that the entire axon is myelinated except for these little spaces in between the Schwann cells called nodes of Ranvier. Also the dendrites and the cell body and the axon hillock are not myelinated, nor are the terminal arborizations of the nerve fiber myelinated. When an axon potential passes along a myelinated nerve, it jumps from node to node, significantly increasing the conduction rates, and this is called saltatory conduction, which is something that you will learn about in physiology. Here is a stained section, I'm not sure what the stain is, of nerve fibers, probably in a dorsal root ganglion, showing these nodes of Ranvier where one Schwann cell ends its myelination of this axon shown here, and another Schwann cell begins its myelination of this same axon. And these axons, here's an axon here, are surrounded by this very thick myelin sheath. And in between the axons we can see the Schwann cell nuclei. So most of the nuclei that you will see in a large peripheral nerve will be those of Schwann cells, although there are some fibroblast nuclei present as well.